Now, if we're going to determine the shape of this molecule, the first thing we have to do is draw the Lewis dot structure of it. And what we have to do here is identify the central atom in the molecule. Now, the first thing we have to do is identify the most electronegative, or the least electronegative atom, which is going to be our central atom. And remember that electronegativity increases as we go up and to the right on the periodic table. So according to that, carbon is going to be our central atom in this structure. So carbon is going to be our central atom in this carbon tetrachloride. And so we're going to determine the total number of valence electrons. Remember the Lewis dot structure for carbon. Carbon has 4 valence electrons and chlorine has 7 electrons in its valence shell. And remember, we identified that by looking at the periodic table and deciding what group it's in. So total number of valence electrons, we have 4 carbon. So we're going to have the number of valence is going to be 4 times 7 chlorine, 7 valence electrons in the chlorines, plus the 4 valence in the electrons in the carbon. So this gives us a total of 32 valence electrons. Now we have to determine the number of bonds that we're going to need in order to make this molecule stable. And so the way we figure this out is it's going to be 8 times the number of atoms, which is 5, because remember it's CCl4. And we're going to subtract the number of valence electrons, which is 32, and we're going to divide that number by 2. And so this is 40 minus 32, which is 8, divided by 2 is 4. So we're going to have 4 bonds. And so what we're going to do now is draw our central atom. Oops, sorry. We're going to draw our central atom with 4 bonds attached to it. And now we have the number of required bonds, and we're going to add electrons so that each valence shell is full. Remember that each bond involves 2 electrons, 2 shared electrons. So in theory, there's 2, 4, 6, 8 electrons around the carbon. There's only, as we've drawn now, there's only 2 electrons around each chlorine. So we have to add 6 electrons around each of the chlorine atoms. And now we have a total of, if we count up all our valence electrons, we have we have a total of 32. Because if we take a look at the bonded ones, this is 2, 4, 6, 8 plus 6 times 4, because there's an extra 6 electrons, unbonded electrons around each chlorine, and 6 times 4 is 24, plus the 8 is the 32 valence electrons. So we've got all our electrons accounted for. So now if we're going to take a look at the shape of this molecule. So here is carbon tetrachloride, looking at it as in a 3D model. And you'll note that there's 1 chlorine on top. This is our top chlorine, and there's the other 3 are out on a plane. And if I tilt this up, you can see that they would be, it looks like they're separated by 120 degrees, but they're not, because they're actually pushed down a bit, and the angle is actually closer to 109 degrees. And the reason for this is the electrons around each of the bonded chlorines are going to repel each other as much as possible. So the shape here of carbon tetrachloride is tetrahedral.